So we are recording on both devices. There you are. What have we here? The mid-chapter quiz. How terribly interesting. What could we do with that? Oh, I forgot I was going to narrate this. Y varies inversely as x. So that is the key. X times y equals k is what we always want to remember when we see that phrase varies inversely. So in this particular case, we can plug in 7 and 28 and figure out that our constant of variation is 196. And so if we're thinking about building a table of values, we just need things with a product of 196, 1 and 196. And of course, these are symmetric, or we can flip them around because multiplication is commutative. 2 and 98, 98 and 2. 3 will not go in. 296. 4 will. It's 4 times 49, or 49 times 4. 5 will not. 6 will not. Now again, we don't have to have integer pairs, so like 10 and 19.6 will work in a minute. Of course, 7 and 28, 28 and 7, and in the middle here, 14 and 14. And again, we don't have to have integer pairs, so we could do 10 and 19.6, or 19.6 and 10 if we wanted, and that would also work. And because k is positive here, because our product, our constant product is positive, it is also the case that all of these could be negative, right? Negative 1, negative 196, negative 2, negative 98, and so on and so on and so on. So let's go ahead and graph those. Inverse variation curves always look the same. That's not my greatest work, but whatever, that's okay. For scale, we'll pick out a couple points. Let's just call that 1, 196, and over here, roughly symmetrical from that, 196, 1. So maybe this one here is like negative 2, negative 98. Maybe this one here is negative 14, negative 14. Over here would be 14, 14. And so on. But that's it. That's the curve for number 1. All based on that constant product. Remember, with inverse variation, that's what makes inverse variation a constant product. Jumping ahead, let's look at number 2. Y equals negative 6 when x equals 9. So, of course, we're going to need a graph again. And this time, if we write down our x times y equals k, it would be 9 times negative 6 equals k. K must be negative 54. So we're now looking for ordered pairs in which the coordinates have a product of negative 54. So that might be 1 and negative 54. Oh, that's interesting. This time the signs are different because the constant product was negative. In which quadrants are my coordinates signs different? Not quadrant 1 or quadrant 3, which is where we were a second ago, right? Instead, we want to be in quadrant 2, which is where, quadrant 4, which is where this one would be, or quadrant 2, where if we changed the signs and did -1 and positive 54, that would be quadrant 2. Of course, things like 2 and -27, 3 and -18, 4 and -13.5. Again, there's no special reason we have to use only integers. We could even use irrational numbers, though I won't, but we could. 5 would work, but I'm not going to mess with it here. 6 is a little bit easier. 6 and -9, 7, 8, and then we would start switching around. 9, -6, 18, -3, or some of these negative ones, -2, positive 27. So let's get the curves into our coordinate plane. Again, this time we're going to be in quadrants 2 and 4. Remember, this is quadrant 1. Over here is quadrant 2, quadrant 3, quadrant 4, Roman numerals. Some points that we might want. 1 comma -54 would be somewhere down here, right? Just as much as -1 positive 54 would be somewhere over there. Maybe that one right there is 9 comma -6. Kind of reversed over here, -9 comma positive 6. But the important part is that the graph ends up in quadrants 2 and 4 because we have that constant product that is negative. And number 3. We've got if y varies inversely as x and y is 3 when x is 6. Okay, we're not going to graph this one. I don't know why we would graph this one. If y is 3 when x is 6, and then we want to find x when y becomes -14 instead, when what? We don't know. X times y equals k. In this case, 3 times 6. Did I get that right? That's interesting. Equals 18, right? So our constant product is 18. And so then I could take that same equation and I could say now specifically, that means that x times -14 also needs to equal 18. Divide by -14, divide by -14, x equals -9/7, also known as -1.285714. Repeating. Why do I know that? I'll never tell. Okay, number 4. Moving right along here. We've only got 31 of these to do. If y varies inversely as x and y is -6 when x is 9. Well, that's the same relationship we saw a second ago. X times y equals k. You can do the ice. It's just going to be super loud. Water break. There's more ice in the freezer if you need it. Okay, no talking on that one. Similar process though, we figured out the constant of variation has to be negative 54 by taking those first two values we were given and multiplying them. And again, that was the same value we happened to graph on number 2. And then we said, well, if x, oh, that's not what I want. If x is 6, right? Right there, it is 6. 6 times what would make that same negative 54? We divide both sides by 6 to get negative 9. And that takes us into number 5. The height of a rectangular tank varies inversely with the area of the base. If the tank has a height of 2 feet when the area of the base is 9 square feet, how tall will the tank be if the area of the base is 6 square feet? So this is a weird way of saying the smaller the base is, the taller the tank is. And so if we made the base much larger, the tank itself would get much shorter. If you want to get fancy about this, the volume of a rectangular prism is simply base times height. So what they're really saying here is that we are keeping the volume of the tank constant. And so if we increase the area of the base of the tank, we have to decrease the height to compensate. If we increased the height of the tank, we would have to decrease the area of the base to compensate. That's all they're actually saying here. So they're saying it has a height of 2 feet when the area of the base is 9. So this would be 9, and this would be 2. In other words, our constant product, which again in this case happens to correspond to volume, would be 18. How tall will the tank be if the area is made to be 6 instead? So actually using this picture, you can see this would be the 9, 2 scenario, h equals 2. Over here, if we instead let this area be 6, then what does the height have to be? Presuming once again that we are going to keep this with a constant volume of 18. So basically 6 times that height needs to equal 18. The height itself must be 3, and that's the answer for number 5. Number 6, state the excluded value. All right, we can speed up a little bit here. 16x plus 5 over 3x. Excluded values are entirely about the numerator. We just ask ourselves, where would 3x be 0? Or we can say that another way, the 3x, the denominator, we cannot let equal 0. Obviously, the only thing times 3 that would make 0 is 0 itself. And so x cannot be 0 is our excluded value. Let's do the same thing on number 7, 12y plus 4 divided by 3y plus 6. Now, there are a couple ways to approach this one. First of all, you'll notice on number 6, on the last one, I did nothing with the numerator. Again, the numerator almost never has anything to do with excluded values. I say almost because when we divide rational expressions, there is a numerator we may worry about. But that's not the case here. There are no operations whatsoever on 6 through 9. We're just looking at denominators. So we can approach this two ways. We can say 3y plus 6, that denominator, must not be allowed to equal 0. So let's figure out what y value would cause such a catastrophe. 3y cannot be negative 6. Divide by 3. Divide by 3. Y cannot be allowed to be negative 2. The other thing we could have done is if we went back up here to the beginning and factored out common factors. Now, again, I don't care about the numerator even though we could factor something. I care only about that 3 we can pull out. I get the linear factor y plus 2. And hopefully by this point in the year you are familiar with the connection between y plus 2 and y equals negative 2. It is a 0. It's the value that would cause y plus 2 to be equal to 0, which again in this case we do not want. So y cannot be negative 2. If we do the same thing on number 8, ooh, do we have room? I don't know. Living on the edge. X squared plus 1 divided by x squared minus 1. Numerator makes no difference. Let's just leave it x squared plus 1, although it's actually not factorable anyway. But the denominator is that difference of squares pattern. So we're going to factor that, x minus 1, x plus 1. Where would these cause me problems? X cannot be 1. X cannot be negative 1. And so those are the excluded values for number 8. Number 9, one more of these excluded value problems. 15x over 3x squared minus x minus 2. Numerator, don't care. 15x, just leave it that way. Denominator, though, that's going to factor, I believe. I'm going to put my 3x squared and my minus 2. And then I'm going to do my table, a times c, f and s. Remember what we mean when we say a times c is that first number times the last number. 3 times negative 2 is negative 6. Are there two factors of negative 6 that add up to negative 1? Yes, there are. They are, in fact, well, maybe I don't know, right? Could it be 1 and negative 6? No. 2 and negative 3? Yes, that's the 1, right? So this is a 2x, and that's a minus 3x. And then I can see a 3x in common, leaves me an x and a negative 1. X times 2 makes 2x. And as always, just to make sure, is it true that 2 times negative 1 is negative 2? And the answer is yes, it is. And so this denominator actually factors as x minus 1, 3x plus 2. Now from there, we can take a look at each one of these. X minus 1, we don't want it to be 0, and so x itself cannot be positive 1. 3x plus 2, we don't want it to be 0, so 3x cannot be negative 2, and x cannot be negative 2/3. So this excluded value applies to that second factor, or comes from that second factor. This excluded value comes from the first. Number 10. Simplify the expression. Okay. 28a squared over 49ab. What do I notice? 7 goes into 28 4 times and 49 7 times. A squared and a obviously have something in common, but when we cancel out that common a, it leaves an a in the numerator. And as always, I like to make sure I remember what is still sticking around. And that's how I get my answer here. This simplifies to the expression 4a over 7b. Number 11, y plus 3y squared, not written in descending powers, which is always annoying, over 3y plus 1. This is the same thing, maybe I shouldn't use an equal sign, maybe I should use the arrow, as y times 1 plus 3y. If you imagine distributing this, you should see why we would get back why we would get back y plus 3y squared. If you don't, we need to meet and talk. Divided by 3y plus 1. Nothing factors out of that denominator. But hopefully you recognize addition is commutative, and so 1 plus 3y is the same as 3y plus 1, and that's why we can say, this is the same as simply y. Number 12, I'm getting a little wild here with the boxes. We've got b squared minus 3b minus 4, and we're dividing it by b squared minus 13b plus 36. So this numerator here factors two numbers that multiply up to negative 4 but add up to positive 1 are negative 4 and positive 1. Two numbers that multiply up to positive 36 but add up to negative 13 are negative 9 and negative 4. I can see that the b minus 4s cancel out, but it otherwise leaves me with b plus 1 in the numerator and b minus 9 in the denominator. Number 13. Ooh, some complicated factoring here. 3n squared plus 5n minus 2 over 3n squared minus 13n plus 4. Well, let's do Bach's method for the numerator. Of course, the 3n squared must have come from that upper left-hand box. Minus 2 comes from there. A times c is negative 6. So I need two factors of negative 6 that add up to positive 5. And those happen to be negative 1 and 6. So negative 1n plus 6n, 3n, n. Positive 2 times 3n makes 6n. Negative 1 times n makes negative 1n. And negative 1 times 2 makes negative 2. So this numerator factors as 3n minus 1 times n plus 2. For the denominator, I need a second box. And again, it has a 3n squared, but this time a plus 4. So in my table, 3 times 4 is 12. Can I think of two factors of 12 that add up to negative 13? I can, unsurprisingly, but hopefully you did also. Negative 1 and negative 12 have the right sum. So that's a negative 1n, that's a minus 12n, 3n, n, minus 4, minus 1. And so this factors as 3n minus 1 times n minus 4. Some common factors that we can now cancel out. Ooh, I need a different color, orange. 3n minus 1, 3n minus 1. And so our answer ends up being n plus 2 over n minus 4. Does not cancel any further, of course, because I have these plus signs that we've spent a lot of time talking about. And I cannot cancel across plus or minus signs. I can only cancel whole factors. 3n minus 1, the whole factor, had a 3n minus 1 in common in the denominator. That's why those canceled. N is not a factor of n plus 2. It's just a part of n plus 2. That would be like saying, oh, 37 must have 3 as a factor because it starts with a 3. No, right? 3 may go into it or it may not, but it doesn't go into it just because it starts with a 3. N may go into n plus 2 or n minus 4, but just because it starts with n, we wouldn't assume that it does. And it turns out that it does not. N is not a factor. It doesn't like multiply up to n plus 2. Doesn't multiply down to n minus 4. So these don't have a common factor. Nothing else cancels. They just stay n plus 2, n minus 4. 14, landscaping, of course. Oh my gosh, there's so many problems. Ken Yi is helping his parents landscape their yard and needs to move some large rocks. I've been there, Ken Yi. He plans to use a 6-foot bar as a lever. He positions the fulcrum 1 foot from the end of the bar touching the rock. If the rock weighs 200 pounds, how much force does he need to apply to the bar to lift the rock? All right, so we have our fulcrum here, and then our bar might look something like that, where this right here is 1 foot. Of course, the bar is 6 feet long, so this other part is 5 feet. We have this big 200-pound rock, and so we need to push down with some amount of force to be able to lift that. We'll call it X pounds of force. Remember, these are inversely proportional to each other. And so what that means is they have a constant product. 5 times x must be the same thing as 1 times 200. So 5x equals 200. Divide both sides by 5. He needs to push down with 40 pounds of force. Good luck, Ken Yi. Number 15. Find each product. Okay, 3m squared. That's not an m. 3m squared over 2m. Definitely some things we can cancel here. Times 18m squared over 9m. I don't want orange anymore. I wish I'd never brought it up. 18 9 goes into it twice, to itself once, though we don't need that, strictly speaking. 2 cancels with 2, that's fun. M and M cancel one of those M squareds, but otherwise, what's left right now? Just a 3 from the first part, just an M squared from the second part. So this is the same thing as 3M squared. And then number 16, can we fit it in? 5a plus 10. I'm just going to go ahead and factor the 5 out because I want this to go a little faster. 10x squared, x, annoying. 10x squared will stay like that. 4x cubed, man, maybe I should have moved this down, times a plus 9a plus 2. And I can see common factors. 5 goes into 10 twice. The a plus 2's cancel out. X squared out of x cubed leaves just a single x. And 2 goes into 4 twice, right? So we end up with 2x over a plus 9. And that would be the answer to number 16. Number 17. Again, I just want to go ahead and start the factoring. Using the distributive property, I pull that 4 out using my difference of squares pattern. N squared minus 25 is the same as n minus 5 times n plus 25. Times n minus 5. And I am going to factor out the 5 there, get n plus 2. And I notice n plus 2 and n plus 2. N minus 5 and n minus 5. I also notice, I bet you did too, I accidentally wrote that down incorrectly. That was just n plus 5, not n plus 25. Only thing left in my numerator is 4. In my denominator, I have a 5 and an n plus 5. But I don't need to multiply that out, so I'm not going to. I'm just going to leave it as 4 over 5 times n plus 5. Number 18, x plus 1 over, can I factor this in my head? Well, I'm pretty sure we factored this already. It was 3x plus 1 times x minus 2. X negative 6x. Yeah, you can use Bach's method to confirm that, but that is the factorization for that denominator. X minus 2 stays x minus 2, and then I see again the ever-popular difference of squares pattern. X plus 1 cancels with x plus 1, x minus 2 cancels with x minus 2. Now, when nothing is left in the numerator, but it's left there by canceling, multiplication and division, of course, that really means there is a 1 there, not a 0, not nothing. 3x plus 1 and x minus 1 are my remaining denominators. Number 19. X squared minus 6 minus x. Again, using my professional factoring skills, x minus 3, x plus 2, x minus 3, x plus 3, times x plus 3, x plus 4, all divided by x plus 2, x plus 2. That one was a little tricky. Two numbers that multiply up to 2 and, that multiply up to 4 and add up to 4 are 2 and 2. X plus 2 cancels. X plus 3 cancels. X minus 3 cancels. And the only thing I'm left with is an x plus 4 over an x plus 2. And again, that does not simplify any further, not in any way that we're going to worry about right now. Number 20. We've got a squared plus 7a plus 10, which factors as a plus 2, a plus 5, over a plus 1, times 3 times a plus 1 over a plus 2. So the a plus 2's are going to cancel, and a plus 1 is going to cancel. And again, we don't need to do the multiplication, so we can just write this as 3 times a plus 5. Should we fit one more? Toys. Yeah, let's do it. Number 21. If a remote control car is advertised to travel at a speed of 44 feet per second, how fast can the car travel in miles per hour? 44 feet per 1 second. But we want to turn this into miles per hour. So first of all, feet. If it's on top, we need to cancel it out by putting the same units in the denominator. Of course, that's a unit of distance, so that's what we're going to turn into miles. And then seconds, we're going to use 2 converters. Because it was in the denominator, we're going to put it in the numerator and turn it into minutes. And then minutes will turn into hours. And then we just need to write all the relationships down. 1 mile is 5,280 feet. 60 seconds is 1 minute. 60 minutes is 1 hour. And from here, we would do a lot of canceling. So feet and feet. Seconds and seconds. Minutes and minutes. And notice the only units we have left over are miles and hours. As far as the numbers go, you can go to your calculator to figure this out if you want to, or you can just trust me that it's going to end up being 30 once we multiply 44, 60, and 60 and divide by 5,280. It should be 30 miles per hour. Number 22. Which expression could be used for the length of the rectangle? Ugh, gross. Okay, well, area equals length times width, right? And in this case, the area, well, I guess so first of all, if we were going to isolate length, this is probably the easier way to do it. We would divide by width, right? So length is area over width, which we might also express as area divided by width. And that's the key for this particular question. The area we know is x squared minus 9. Let's put it over 1 to make things easy here. We're going to divide that by x squared minus x minus 12 itself divided by x minus 4. I think there's something wrong with this question. At least the way it's written for me. Maybe not. Maybe I'm getting ahead of myself. I did that last time. I thought there was something wrong with the question, and it turns out I don't know, wasn't imaginative enough or something. So this numerator is another difference of squares pattern. You should be getting tired of me saying that. I hope it is familiar to you. X minus 3, x plus 3, switch, right? Let's go ahead and turn that into multiplication and flip. And x minus 4 goes on top here. And then that factors x squared minus x minus 12 as x minus 4, x plus 3. Okay, I did get ahead of myself. I should have been more patient. The x minus 4's cancel, the x plus 3's cancel, and the only thing I'm left with is x minus 3, which is answer choice C here. So, fine question. I should not have cast aspersions upon it. More division, a over a plus 3 divided by a plus 11 over a plus 3. We're going to turn that into multiplication and flip a plus 3, a plus 11. Of course, we have a over a plus 3 here already. And we should be able to see, the a plus 3's cancel. And so we're simply left with an a in the numerator, a plus 11 in the denominator. And again, that does not simplify any further. Number 24. 4z plus 8, which I am going to go ahead and factor here, 4 times the quantity, z plus 2, over z plus 3, divided by, I guess let's write this out, divided by z plus 2. Now, if this were just a 2, let's say, how would we flip, right? How would we do the reciprocal? Well, 2 is really 2 over 1. In much the same way, z plus 2 is really z plus 2 over 1. And so that's what you would do. And then in the next step, that's going to turn into times 1 over z plus 2. And again, the rest of this is just going to stay the same because we already did our factoring there. Once I do that, I should be able to see, okay, so the z plus 2's cancel out, and I'm simply left with 4 over z plus 3. And that's my answer for 24. I bet I can get 25 in here. Similar situation on 25, we have b squared minus 9, which of course is the same as b minus 3, b plus 3, and it's being divided by 4b, or it's over 4b. It's being divided by b minus 3. That's really going to be times 1 over b minus 3, using those same reciprocals. The b minus 3's cancel, and we get b plus 3 over 4b. Now this is the first one we've gotten where we could cancel further if we wanted to by using some of the techniques from the 11-5 lesson. But I'm not going to worry about that. There's no particular reason we have to. B plus 3 over the quantity 4b is fine as an answer. So I'm just going to move on. 26, we're getting there. 37 minutes, my gosh. M squared minus 16, so that's m minus 4, m plus 4, another difference of squares, over 5m, we're going to go ahead and switch flip here, times 1 over m plus 4. Man, they are really getting some similar problems in here. So we're going to leave that as m minus 4 over 5m. And I just looked back to make sure, is it saying anything about excluded values? And it is not. 27, okay. So they factored it for us. I have no idea why. 2x minus 1, x minus 2 over x minus 2. Already some cancellation you can see. X minus 3, switch, times, flip, x minus 3, x minus 1, 2x minus 1, x plus 5. 2x minus 1, 2x minus 1, x minus 2, x minus 2, x minus 3, x minus 3. And so this is x minus 1 over x plus 5. Number 28. All right, this is the first one where we definitely want to do 11-5 style strategies. 9xy squared minus 15xy plus 3, and the whole thing is divided by the monomial 3xy. So what they want us to do here is rewrite this in 3 separate terms. Minus 15xy over 3xy plus 3 over 3xy. And then cancel individually. For this first term, x and x cancel. Y squared and y leave a y. 9 and 3 leave a 3. And again, because of the minus sign, that term is totally separate from anything else. So I'm just going to put 3y. 3 goes into 15 5 times. X cancels with x, y cancels with y, minus 5. 3 cancels with 3, and that's it. 1 over xy. And that's what they want to see on number 28. We're almost there. We're so close. My phone's running out of room for this video. Number 29. Goodness, I hope the audio syncs well on this one. 2x squared minus 7x minus 16. They want us to divide. They want it with long division. How do I know this? Well, there's no factoring you can do out of 2x squared minus 7x minus 16. At least I don't think there is. Negative 32, two factors of negative 32 that add up to negative 7. I don't believe so. 4 and 8, no. So that's the main way I can tell. The factoring doesn't work. Nothing cancels here. But I can do the division. What times 2x would make a 2x squared? And hopefully you are playing at home and you can say x. And then we multiply, just like in regular long division. X times 2x is 2x squared. Those two match. They always should. X times 3 is 3x. And of course, I remind myself I am subtracting all of this. Negative 7x minus 3x is negative 10x. Bring down the minus 16 and keep going. What times the 2x makes a negative 10x? And the answer is minus 5, right? Negative 5 times 2x is negative 10x. Those match. They always should. Negative 5 times 3 is negative 15. And so I'm going to subtract here. Negative 16 minus negative 15 is really plus 15, which is negative 1. That's my remainder. So I get x minus 5 minus 1 over 2x plus 3. That's the answer to 29. So close, so close. Number 30. I don't think I can fit it here. I'm going to do it over here. Number 30. Y squared minus 19y plus 9 definitely does not factor. Let's do the long division again. Y minus 4 goes on the outside. Y squared minus 19y plus 9 goes on the inside. What times y makes y squared? Y. Multiply it out. Y squared minus 4y. Subtract. Y squared minus y squared is 0. That should always happen. Negative 19y minus negative 4y is negative 15y. Bring down the positive 9. And then what times y makes negative 15y? A minus 15. Negative 15y, positive 60. So again, we are subtracting here. 9 minus 60 is negative 51. Crazy remainder. And so this becomes y minus 15 minus 51 over y minus 4 when we do the polynomial long division. One last problem, number 31. Anoki wants to put a decorative border 3 feet above the floor around his bedroom walls. If the border comes in 5-yard rolls, how many rolls of border should Anoki buy? Where does he want to put it? 3 feet above the floor. I'm just going to miss this question. Can I do that as the teacher? Gosh, what do they mean? 34.5 inches? 42-inch doors? Why? Why, Anoki? Oh, 60. All right, so we take our full perimeter, which is 14 feet by 12 feet, doubled, of course, twice the sum of the length and the width, and so that's 52. So we have a 52-foot perimeter, minus 42 inches, which 42 inches we would need to convert by remembering that 1 foot is 12 inches. So if you do 42 over 12 in your calculator, you get 3.5. So minus 3.5 feet, minus another 42 inches for some kind of door. Well, fortunately, we already know that's 3.5 feet. And then 34.5 inches twice, I guess that's 2 windows, makes 69 inches that we're going to convert the same way, 1 foot per 12 inches. The inches here are what's canceling. That's how we're turning these into feet. And as you go to your calculator, 69 over 12 is going to be just under 6, 5.75, I believe. So minus 5.75 feet. Okay, 7, 12.75, 40.25. I'm pretty sure is what this should work out to. But Anoki is going to buy it in 5-yard rolls. So 40.25 feet, we are going to convert into yards, and 1 yard is 3 feet, and 3 goes into 40, 13.41666 on and on forever times 13 yards, but they only come in 5-yard rolls, so he needs at least 3 rolls of 5 yards each. Because 3 times 5 is 15, and 15 is more than what we need, but not less. We can have more, we can't have less. Okay, so there it is. 45 minutes. I guess I couldn't have given you this in class, but I didn't. I did this instead. You're welcome. Enjoy. Namaste.